Okay, so we're going to go ahead and talk about mass versus weight. So mass is the amount of matter in an object, and it is going to be the same everywhere you go. So no matter if you go to the moon, if you go to the middle of outer space, if you go to your home, if you go to the mountains, your mass is always the same. And mass will oftentimes be measured in kilograms. While your weight, that is just by definition your gravitational attraction to the Earth. So this is the gravitational force acting on an object. And it is just your attraction between you and the Earth. So it basically tells you how attracted you are to the Earth. So let's go ahead and go through some examples. Okay, so let's say I happen to have Isabella. So let's say Isabella has a mass of 60 kilograms. So, okay, let's find a couple things. So we know that the force of gravity, I'm going to go ahead and introduce the equation, is going to be mass times your acceleration due to gravity. So again, Fg is your force of gravity, which sometimes people write as Fw, so just for weight. So people kind of use those synonymously. M is your mass that stays the same everywhere, and G is your acceleration due to gravity. And keep in mind, G is always going to be positive. So this is always a positive number. We'll worry about directions when we draw free body diagrams, all that good stuff, but G is just always positive. Okay, so let's go ahead and find Isabella's mass and weight on the Earth, Moon, and in outer space. Feel free to try it yourself and then check back in. So on Earth, we know that G is 10 meters per second squared. Her mass is not going to change. It's always going to be 60 kilograms. Her weight, let's plug it into good old Fg equals mg. So her weight is what? 60 times 10. So 600 newtons. Cool. So now let's go ahead and look at the moon. So on the moon, we know G is about, you don't have to memorize this, but it's around 1.6 meters per second squared. So less than it is on the surface of Earth. Mass is 60 kilograms. Still, her mass is not going to change. So let's plug it all in. So Fg equals mg. So what? 60 times 1.6. And I get 96 newtons. So she weighs way less on the moon than she would on Earth. That's why you get more of that floating sensation. Now let's say she goes into outer space. And let's say she goes to outer space where there's no massive planets or no massive objects nearby. If that's the case, then her acceleration due to gravity is just going to be, the acceleration due to gravity is 0 meters per second squared. Her mass is still 60 kilograms. No matter where she goes, good old mass, 60 kilograms. Her weight then, oh my goodness, I'm sorry, I struggle with the computer. Let's go ahead and plug it all in. So it's what? Mg. So her mass is still 60 times z, z, 0. So this is 0 newtons. And in this case, she would feel weightless. So you don't feel weightless because of your mass. You feel weightless because of the force of gravity acting on you.